We are bunching together 7-1 and 7-2, and it's graphing. So we don't go in a lot of detail on graphing because this class is not getting you ready for 1400 college algebra. It is just a basic level math course. So basic college math class. So we are just going to touch on the idea of graphing and graphing functions. So if you look at this first idea that I have on here, it says, okay, here's our objectives, right? But going down here, all equations in this form, ax, an x, a y, a number, are straight lines when graphed, right? That's called a linear equation with two variables. So this is called a linear equation with two variables. Basically, you have an x and a y. You could be in the form y equals mx plus b or ax plus by equals c. They're just written differently, but they're the same thing. Their graph is a line. They are related by a specific rate, okay? And a rate in real life could be a price. So a rate or a price. Okay, so we have something called the X Intercept, the Y-Intercept. These are where your graph of whatever your line you're forming is crossing the axis. So let me show this on here. This here is called your x-axis. This one here is called your y-axis. And just for the sake of explaining these, I'm going to graph some kind of line on this graph. Here's the line. Where it crosses the y and where it crosses the x are the intercepts. So where it crosses the y is the y-intercept. Where it crosses the x is the x-intercept. Okay, y-intercept, x-intercept. Now, looking here at this x-intercept, we don't go up or down. We just went from the origin. We just went, left to right. We just went left, but we could go right as well. So we just went left to right. So when we're on this line, the y is 0. So to find the x-intercept, the y is 0. Same idea for here. In order for the y to just go up and down, you didn't move sideways. So to find the y-intercept, x is 0. So scrolling back up to these intercepts, this is saying to locate the x-intercept, set y equal to 0 and solve. And for y, you let x be 0 and solve. That's how you find those. They're a point, though, so you have to keep the 0 and the number you got for that point, and I'll show you that. Hey, that rate that we talked about is a slope. Slope is a rate. Okay, that's what it is. Sometimes you're taught it's rise over run. Sometimes it's a change in y over change in x. Sometimes you see the formula. Look at all the things that are the slope, right? So slope is just how steep that line is. So this red line here, it's fairly steep. But if I drew a blue line that maybe is not as steep, right? Then the slope of the red line will be bigger than the slope of the blue line because it's growing faster. It's going upward faster, larger slope. We also could have a negative slope. So I don't know, let's go with pink. Negative slope is going down to the right. So positive slope is growing to the right. Positive slope, positive slope. This is our positive section. You're going bigger this way, you're going bigger this way. Positive, positive. So things that have a positive relationship is the more you study, the better grade you get, right? So those are positive relationship. Now this pink line has a negative relationship. As this one over here gets bigger, this one's going down. So as x gets bigger, y is going down, or it's decreasing to the right. Something that could have a linear relationship where one's going up and the other's going down. Why can't I think of one off the top of my head? Where one thing goes up, the other goes down. Shoot, the only thing I could think of is the more items you sell, the less the more items you sell, the less your inventory will have. One goes up, one goes down. It's the only thing I could think of off the top of my head. Okay, now we go into the first example here, and now I have drawn all over this graph. So if you need to pause and look, do, but I am erasing everything that I added to that graph. Okay, and then it magically wipes it away for me. Man, I like this app. All right, so I'm on Notability app if you want to know. It works great on an iPad if you want to do it for your notes. Okay, so well, I could have kept the X and Y axis. So here's the first kind of equation right here that we're given. 3x plus 2y equals 6. And does it say example 2? It just says graph. So a couple things I want to make sure we do with this one is I want to show the intercepts with this as well as graph it. So the directions aren't completely what I want. So bear with me. I want to find the X, or we'll start with the Y, intercept. So what did we do to find the Y-intercept? We let X equal 0. So let X equal 0. So writing this equation back down, 3 times 0 plus 2y equals 6. So the 3 times 0 goes to 0, so I really have 2y equals 6. Divide both sides by 2, and y equals 3. So what was this point? Remember, the points go x, y, right? X, comma, y. And this, the x was 0, the y was 3. So let's graph that point 0, 3. So we start at 0, always, and we go 0 this way, and then we go up 3. So we're here. All right, so there's a point on our graph. So let's find the x-intercept. And this time we're going to let y equal 0. That's a L, let. It'll kind of look like a 6, but it's L-E-T. So if y is 0, you would have 3x plus 2 times 0 equals 6. 2 times 0 is 0, so I really just have 3x equals 6. Divide both sides by 3, divide by 3, and x is 2. So put the point together. 2, x was 2, y was 0. So go back on your graph, start at the center. We go over 2 for x and 0 for up and down. So we're right there. Okay, so this is the graph of that line. Using the intercepts, and you will get it wrong if it asks you to use the intercepts and you don't. Even if you graphed it right, you will get it wrong. Okay, so that is how I found my intercepts on this problem. Bear with me for a second. I'm going to show you another method, and I'm just going to have to erase over here just for a second. And I'm going to erase the line just to show you again. Just a little bit different way. So right then I just showed the intercepts. Now I want to show with a chart, okay? So another way to graph would be from a chart. So I have X, and then I'm gonna leave a little space and a Y. And when I do a chart like this, I just pick an X value and I find the solution, and then I find the Y. So it's any correlation of the X and Y. So we have to be careful with this one because it's gonna form a fraction of, yeah, you might have to play a little. It might be harder, or put in the zeros, which is what we just did. But let's try putting in, so if I put a 1 in, I like to put in zeros and ones, but if I put a 1 into X, I will get a fraction answer. Right here, let's put in a 2. Okay, and watch what happens. So that I made that up. Okay, I make up a number and I find which y will work. Then I would have 3 times 2 plus 2y equals 6, and you have to then solve that. So this is going to give me 6, right? Plus 2y equals 6. Subtract the 6 over and I get 2y equals 0. 0 divided by 2 is 0. I just found the point 2, 0. Which was also an intercept. Okay, and then in my brain, if I use a 4, and the reason why is because I need them to be divisible by 2. So whatever I times by 3, it better give me something divisible by 2. So my brain just went that way. So you might not think that way, and so I would just use the zeros if you can. So this one, I could do 3 times 4 plus 2y equals 6. Couldn't you always just do it a multiple of whatever the number is by the y? For the most part. So most part, you can do what's by the y is a 2. So you could do 2, 4, 6, 8, 10, any multiple of that 2. And it should come out without a fraction. Do I really care if you get a fraction? No. And I don't care if you have to graph 1.6. Can you graph a fraction in my math lab? No. Yeah, so that's the kicker. All right, so 3 times 4 is 12, plus 2y equals 6, minus that 12 over, and I get 2y equals negative 6. Divide both sides by 2, and I get negative 3. So I'm going to go to 4, 1, 2, 3, 4, and down 3. 1, 2, 3. Over 4, down 3. So this right here is your line. See how good I can draw it? There we go. And this is still, gosh, it doesn't quite look like it crosses at the 3. But yeah, it's over 2, up 3. I mean, here's the kicker. This should cross at the 3 like the intercept, but I'm hand drawing, so it's definitely not perfect. When you go to my math lab, you pick the line and then you click on one of the dots that you want, and then it'll move around. Then you click on the second, it'll make the line for you. Okay, so 2 ways. Intercepts, putting in the 0. 0 for x, solve. 0 for y, solve. That finds 2 points for you. Or you can make a chart like this and find 2 points. Okay, the next one just asks, what's the slope? So we have 2 ways to do this one. If we want the slope, we can just graph it. So it's negative 3, 1, 2, 3, down 1 is here. And negative 2, 1, 2, up 4, 1, 2, 3, 4 is here. And you want the slope between those. So that's rise over run. So you can go, okay, from one point to the next, how far do I run? I run 1, right? And then you go up 1, 2, 3, 4, 5. So I got a slope of up 1 or over 1, up 5. Rise over run though. I did it backward, didn't I? Rise. Shoot. I totally did. Sorry. I don't know what I was thinking. Rise over run. We're fine. This is oops, I didn't mean to do that. I had it on erase. 1, 3, up here, 4. Is our dot. So we said over 1, up 1, 2, 3, 4, 5, but we want to do rise over run. So 5 over 1. Okay, let's do that with the formula as well. Y minus y over x minus x. So our y's are the second numbers. So we want to subtract those on top. So negative 1 minus 4 more. And then on the bottom, we have negative 3 minus 2 more. So negative 3 minus a negative 2. Okay, so that's our formula. And then just work with your integers, right? So negative 1 minus 4 more is negative 5 on the top. And this becomes a positive because it's a double negative. Negative 3 plus 2 is a negative 1. And a negative over a negative becomes a positive. So we get the same slope whether we count them or we subtract them. Why would we have 2 ways? We always have more than one way. Because what if your points are at like 95? You're not going to count all those, right? Ups and downs. So this one was fairly easy to count, up 5 over 1 or over 5 up 5, 1, either way. But this method is more reliable, easier to use on most things. Okay, slope-intercept form is that other form of putting an equation in the form y equals mx plus b, where this actually shows us our slope. M is our slope, b is our y-intercept. That's what's here, right? That's super nice. So if I took ax plus by equals c, whatever that function was, and I rewrote it to be y equals, it would be in this form. So I could rewrite this function to be y equals this one right here. I would minus the 3x over, divide by the 2. I might just show that. Minus the 3x over, now divide by the 2, and then divide each term by the 2. And this would become, write it up here, y equals 3 minus 3 halves x. I like the x term to be written first, so I could then rewrite it as negative 3 halves x plus 3, because the 3 was positive, so plus 3. So this is the same thing as this. Those are equal, but they're different forms. Now I see the slope. I see it has to cross at 3. I'll make the 3 really big so it looks like it crosses at 3. All right, let's go back down. So in this form, we just like it because it shows us lots of stuff. I kind of give you some stuff about it here. Okay. Oh, that fraction came through weird. All right, this says just graph it using the equation. Let's rewrite that equation. It is 2/3 x plus 2. It's just kind of weird right there, right? Well, we'll just cross it out and go with that one. Okay, it wants us just to look at the slope and y-intercept. So we have a cool trick that we can use knowing that the rate is rise over run. So we look at this one. I'm actually going to change this even more. I'm going to change this to a negative, unless I have another one with a negative. I don't. Okay. All right, because we haven't done a negative slope, so I want to do that. You can put the negative in front or with the 2. Same thing. So this says it has a y-intercept at 2. What does that mean? Well, it means it crosses the y right here at 2. So that is a point. Cool, I got a point. I only need 2 points to draw a line. So I can follow the rate, the pattern of 2/3, right? That's our slope, where our m is negative 2/3. And this is your slope, okay? And that is rise over run. That means from the point we're currently at, we could rise negative 2. Well, how do you rise negative 2? You go down 2. So instead of going up, I go down because it's a negative. So I'm going to go down 2 and then over 3. Okay. And that's going to be down 2 over 3 right here. I could keep following that pattern, down 2 over 3, down 2 over 3, and that would stay in that line. I could also, if I go up 2, go in the negative direction this way. That would be like thinking of it as 2 over negative 3. So that negative 3 is going in that left, that negative direction, and those all are the same idea. Okay, because I could write this like this, or I could write it like this, or I could write it like this. And I always just go with this way so that I remember to go down, right? Down and then to the right. I don't want to go right or left because when you show your hands, it's backward and whatever. Okay, so this is our line, whoop, like this. And then you just draw a line through it. You only need 2 points, but we did 5. It's fine. Okay, then we have this function. We already did one like that. Not too worried about that one. Let's do one more instead of the one that was written on there. Let's do another one that is like, oh, I don't know, 2x minus 1. Okay, if I want to graph this again using just slope and y-intercept because it's in y equals form, so I don't have to do a chart or put in the zeros for the intercepts. I can start at the -1. That's our y-intercept. So start at -1. And then you need the slope to be a fraction. So just put it over 1. Then I'm going to go rise up 2 over 1. So up 2 over 1. Up 2 over 1. Up 2 over 1. And that's our pattern. Up 2 over 1. 2 to 1. Okay. Man, I did not draw that line through those dots. Okay. So what happens if you have a horizontal line? It's weird. It never crosses the x, so it doesn't have an x in the formula. It's just y equals whatever number. Okay. Vertical's the opposite. Vertical line, right, is straight up and down. It's down here. So when I have a vertical line, then it is x equals, it doesn't cross the y, so they're always x equals for a vertical line. Y equals horizontal, x equals vertical, okay? So then it says graph these lines below. I want two graphs. Wish I could copy that one, but it's okay. Here's your x, here's your y, here's your x, here's your y. So for this one, this represents one line. Is x equals vertical or horizontal? Vertical. So go to that x equals -3, 1, 2, 3, and you do a vertical line because x is equal to -3 all the way on that -3, right? Next line, y equals 4. Okay, this one we go to where y equals 4. 1, 2, 3, 4. This is 4. And y equals 4 horizontally all the way across. Y is 4. It doesn't matter what the x is. Y is 4 all the way across that line. So there's those two lines. I didn't draw them together because then if I put it on an exam, you'll think that they should be drawn together, and they're totally different lines. Okay, what is function notation? Function notation is just a different way to write our y value, kind of. We like to see the input and the output all at once. So I have notation y equals f of x, right? This is huge. So y equals the f comma, or not comma, parenthesis x. That is function notation, and it's read y of x, or f of x, excuse me. So that notation is function, and what it really represents is it shows your x and your y values at the same time. So if x equals 7, then you would write it like this in function notation. That 7, the x goes in that parenthesis. Okay, okay, so they're saying, I was trying to realize what I showed all the work on this one, so then it confused me. So here's the function right here. If I am saying x equals 7, you could solve and find y. So I put that x value, right? I put that 7 in for x. Right? It gets, if it had a 7 here, it goes in here, and that's what this is showing here. So 7 minus 4 is 3. So if I wrote that, f of 7 equals 3. Can I see what I put in? Yes, and what I got out. That's why people like this notation. I put in a 7, I got out a 3. If I just said y equals 3, which is the exact same thing as what I'm looking at, you did not know the x value to get 3. Well, you might, but like it's harder to see. So this shows what you put into the function to get the answer of 3. It follows computer science. It kind of goes with a lot of things. Okay, so A here. If this is our function, so this is the same as y equals, or f of x, what if f of 2, or what is, not what if, I'm done. I can't talk today. What is f of 2? Where do we put that 2 value? We put it in for x. So f of 2 would equal 2 times 2 plus 1. 2 times 2 is 4, 4 plus 1 is 5. So that's our answer there. To find the f of -5, I would put that in 2 times -5 plus 1. 2 times -5 is -10. -10 plus 1 is -9. So you're putting those in for x. This didn't show what I want. Okay, what if, using the same function, what if you say f of x equals 10? What is y? Or find y? So f of x means y. So if I'm asked to find y and I'm given the function equals this, then I'm putting that function, this 10 in for that function like this, like solving backward. So I'm putting that 10 in for the function x. Now I could minus the 1 and I would get 9. Oops, I didn't do it right in my head. That's okay. Here we go. We're going to get a fraction answer. That's okay. So divide by 2, and I get 9/2, which is the same as what? 4.5 or 4.5. So that's what our x value is when y is 10. So you can work the other way and it'll just say that full f of x equals a number. So if they put the number in like this, that means put it in for x. If they say f of x equals, that means that's y. And then solve back or forth, whatever one. Okay, so I have one long nonlinear function. Basically, if you're graphing any function, anything that we have, we can use a chart and graph that function. And that's what this problem is showing. This one's not a line, it's non-linear, right? So I'm putting in the values it gave me, but you can really make these up. You could have done 1, 2, 3, 4, 5 and seen what the graph looks like. So we're going to put those values in. I don't really have a good place to show the work, so maybe I'll write it over here. So basically, it's going to go -2 minus 6 squared. -2 minus 6 more is -8, 7, 8, -8, whole thing squared. So -2 or -8 times -8 is positive 64. Oh man, I'm definitely not showing that on my graph by ones. Okay, -1. Then we would have -1 minus 6 more squared is -7 squared. Well, that's 49. -7 times -7. Notice the parenthesis, that whole thing is squared. Okay, then we're at 0. Well, 0 minus 6 is just 6, so 6 squared is 36. Okay, 1 minus 6 is -5. -5 squared is 25. And then 2 minus 6 is going to give me 4. 4 squared is 16. Oh, it's like squares all the way down, right? So to graph this, -2, positive 64. What should we count by? 10. 10's maybe, no, we should just count by, maybe we'll count by tens. 10, 20, 30, 40, 50. It's just 60. That's all right. And then we'll just count by regular 1, 2, 3, and so forth on this one. But go over -2 up 64 would be somewhere right in here. That is not a perfect graph at all. And then -1, 49, -1, 49 is about there. 0, 36, so 0, then 36 is right about there. And then 125 is about, oops, I didn't do it on the 125 is there. And then 216 is somewhere in here. And then we can't really see this graph. It totally looks like a line. Yeah, this isn't a very, we got to put in a couple more numbers. Let's put in like, maybe let's put in like 10 and see what we get. So 10 minus 6 squared is 4. 4 squared is 16. So at 10, 3, 4, 5, 6, 7, 8, 9, 10. Gosh, that's up at 10. I'm back up at 16, just about here. It just doesn't show it, but this graph is going to go something like this. I just don't like that the numbers I picked obviously weren't, I wonder if I got those cheap. No, I don't know what I did. I should have done like -1 instead of -6. Clearly it was me. But if you have something non-linear, it should not form a line. And any square forms a U shape, okay? But put enough points in that you can see that graph. All right, so basic ideas to take away. Let me go back up to the top. Basic ideas to take away is you can find intercepts by putting in 0 for x, find y. 0 for y, find x. Okay, you can find slope. You can graph a line using a chart always. Or you can use slope and y-intercept if it's in the form y equals. Okay, you can graph horizontal or vertical lines. They're only y or x equals a number. Slope as a rate, you just need to know slope's a rate, and you might do a word problem with that. And yeah, and then I think that's pretty much the model data. Basically, you know, can you model, I don't know, can you take a word problem and solve kind of with the ideas with that model ideas? Okay, let me know if you have questions. This section is supposed to be like a review of functions and that notation a little. We don't touch a lot of this idea because this is 930 stuff, but we touch a little.